Hi, my name is Santiago Rodríguez and I'm going to solve the following circuit using the super mesh method. So here we have a circuit in which we have 4 resistors, 2 voltage sources and 1 current source. Therefore we have a super mesh and we need to get Vx and power. First of all, I'm going to label the direction of the 4 of my currents as shown in the screen. I4 has a different direction because of the battery, because of the voltage source. Now I will use Kirchhoff's voltage law to solve my meshes. And first of all, I need to take into account that between I2 and I3, I have a super mesh because of this current source. So first of all, for my mesh number 1, which is the one on the left, I have minus 5 plus 30 I1 plus 45 I1 minus I2 equal to 0. This is equal to 75 I1 plus minus 45 I2 equal to 5, and this is my equation number 1 in my first mesh. Now I'll solve the super mesh. So here I'll write SM23 because the super mesh is between meshes 2 and number 3. First of all, I have 45 I2 minus I1 plus 54 I2 plus I4 because of the direction of the voltage source plus 91 I3 equal to 0. And from here we get these values for my second equation. 54 I4 equal to 0. This is my second equation. And because of the current source in between my super mesh, I have the following equation as well. I3 minus I2 is equal to 1/4 of an ampere. This is my equation number 3. And for the mesh number 4, my equation will be minus 1 plus 54 I4 plus I2, also because of the difference in the direction. And I clear for these values, and I get the following. This is my equation number 4. And in order to solve for all of these, I will put these values into a software that solves matrices. Equation 1, equation 2, equation 3, and equation number 4. And I get the following values. I1 is equal to 0.047 amperes. I2 is equal to minus 0.190 amperes. I3 is equal to 0.0596 amperes, and I4 is equal to 0.209 amperes. So now that I have my 4 currents, I need to get my Vx. So as we can see in the diagram, Vx would be equal to 45 times I1 minus I2. So we substitute the values and we get 0.047 plus 0.190, and we get that Vx is equal to 6.435 volts. And now we need the power in the current source. So in order to get the power in the current source, we need to get the power of this mesh. So we need this voltage drop. So in order to get the voltage drop of I3, we use the same procedure we used to get the other voltage drop. So we have a resistor of 91 multiplied by 0.0596, which is the current. And we get that the voltage drop in the mesh number 3 is 5.424 volts. And the power is the voltage drop in 3 times the current of the current source. As we can see over here, it is 1/4. So we substitute for the power 5.424 times 0.25, which is the same as 1/4, and we get that the power is 1.356 watts. And that's how we obtained all of the values required in the problem.